Now we want to solve using the properties, using the equivalent form to solve the exponential and the logarithmic equations. Some simple ones, okay? So the one problem is 11 to the x equals 7, right? So we know one way is to solve this one way is we use the equivalent form. That means x equals the log with base 11 of 7. Right? You can solve this one quickly. And if you use but the more common way is, since these two are equal, then we can take the same logarithm on both sides, it will still be equal. So here, for our convenience, we take the natural log on both sides. So you will have the natural log of 11 to the x equals natural log 7. So this is the x is in the power, so you can bring down in front of natural log. So this would be x times natural log 11 equals natural log 7. So x is equal to natural log 7 over natural log 11. Then you can use your calculator to do the calculations, right? So here I just help you do a little bit. So the natural log, you can check by yourself. So here is the natural log of 7 equals 1.945910149. If you are not very familiar with your calculator, you'd better to keep as more decimals as possible. Okay, divide by natural log 11, which is 2.397895273. If you do the calculation, you will get 0.81150753. If the problem asks you to keep 3 decimals, right, then you will have 3 decimals. So you will have 0.812, okay? So why we like this form, the reason is if you have this one, you cannot use your calculator, the general calculator, to do the calculation for the log to the base 11 of 7. But we will see, you can see that this one is the same as this one. Okay. Is the same as this one. So this is the way to compute this logarithmic function. We use the natural log to compute the logarithm for this general base. Okay. So here is some comments, remark for this one. This tells you that the log, we can say this b a of a to the base of a is equal to the natural log of a over natural log of b. You can use this way to calculate the arbitrary base b using your calculator. This is also called change of base formula. We change the base from base b to the base e, right? The second example, Another example is 3 to the x plus 2 minus 1 equals 10. So the first thing is you need to add 1 to combine the like terms, right? So you need to isolate the x terms and the constants. So we add 1 on both sides, so you have 3 to the x plus 2. So here this 2 is in the power, not plus 2 outside, okay? This 2 is the part of the exponent. Is equal to, we add 1 on both sides, you will have 11 here, right? Then what we should do if we have this form, we have some exponential form equals a constant. The way is we would like to do is we take the natural log on both sides. Natural log 3x to the x plus 2 and the natural log 11, right? And then we have the properties that for this position you have the power. This power can be bring down in front of natural log, so this would be x plus 2, this is the power. You use the parentheses, okay, times natural log of 3 is equal to natural log of 11. So x plus 2 is equal to natural log 11 over natural log of 3. So now we subtract 2 on both sides. So x is equal to natural log of 11 over natural log of 3 minus 2. Okay. So this is the example which is called the doubling time. Okay. It means how long will it take the principal P to double if it is invested at 15% compounded annually. Okay, so this is the example. So since this is the compound interest, we want to use this formula. A is equal to P, the principal, times X plus R is the annual rate over M. How many times you get the interest every year? You will be computed for the interest every year and M times T. Okay, so we know that we want to know at last the principal will double. That means if the principal is P, so A should be, this is the final, the future value should be doubled, so the future value is 2P, right? So here the R is 15%, so it's the 0.15. And M, since this is the compound annually, so M equals 1. So if we plug in everything, so we want to know what is T. How many years you will get the double principal. So this is the 2P equals P times 1 plus 0.15 over 1, right? So this is the 1 times T equals T only. So if we simplify, this is P divided by P on both sides, you have 2 equals, this would be the 1.15 to the T. How to solve for T, right? So this is the exponential form. We can just take the natural log on both sides. So we take the natural log on both sides. Natural log of 2 equals natural log of 1.15 T. So we know we can bring down T in front of the natural log. So it's natural log of 2 equals T times natural log 1.15. Then T is equal to what? Natural log of 2 divided by natural log 1.15. If you do the calculation, it is 4.9595 years. So in other words, it's about 5 years. Okay, in 5 years, your principal will be doubled under the annual rate 15% compounded annually. Okay, so this is the one application to the logarithm in this section.